Okay, today's lesson is lesson 16.7, Operations in Scientific Notation. This is a big lesson. I probably, if I were doing this, if I were writing the textbook, if the textbook company would have asked me, I probably would have separated this lesson into two separate lessons, one where you are adding and subtracting and another one where you are multiplying and dividing, but your book put them all in one. So you might have to rewatch because it really is too similar, but it's really two separate ways of doing scientific notation. So this is essentially looking at a shortcut method using scientific notation, because scientific notation is a type of shortcut method of writing numbers, and you're going to do operations on the scientific notation. So you're going to add and subtract and multiply and divide scientific notations. So, and then it allows you not to have to write them into large numbers, add them, and then put them back. This way it allows you the opportunity to just look at the factor or the decimal number that you're working with. So with scientific notation, let me get my little highlighter on here. With scientific notation, you're going to add or subtract numbers that are written in that same power of 10. You're just going to add and subtract the factors. That's if they're in the same power of 10. Now that's a big deal, because if it's not in the same power of 10, that's a same power of 10, you're going to just add or subtract the factors. However, there are going to be times where it's not in the same power or in the same power of 10. So when the numbers have different powers of 10, you're going to rewrite the numbers so that they have the same power of 10. So you're going to manipulate. So let me just get to they have different powers of 10. You're going to manipulate those numbers to make them the same power of 10. And then at the end, you have to manipulate it back to make it the correct form of scientific notation. So there's a lot of stuff going on here, okay? And it is not always that simple. So what I did at the right here, I wrote down some steps or things that you need to do when doing this. So I would suggest that you write this down. I want you to write this down in your notebook. So to add and subtract in scientific notation, the first thing you're going to do is you're going to look at the power of 10. If the exponent is the same, you're just going to add or subtract the factor, the decimal, and then bring down that power of 10. Then you're going to rewrite that decimal to make the scientific notation in the correct format, changing the power of 10 appropriately. Okay, now that's can be easy if it's positive exponents. It can be confusing if it's negative exponents. Even I, when working out these problems, got a little confused, and so it's important that you really pay attention when it's negative exponents, because that's where you'll probably make your errors. Now, if the power of 10 is not the same, you're going to manipulate the scientific notation, making the power of 10 the same. So there's an extra step there. This will make the scientific notation not in the proper format, and I understand that, but you're going to do an operation on it anyway. Then you're going to add or subtract the factors or the decimal, and then bring down that power of 10. Then once you do that, you're going to place the answer back into the proper format and change the power of 10 appropriately. Now, you have to add or subtract the factor decimal, but then you also have to add or subtract the power of 10. And I probably should have written that in here. So let me just, real quickly, I'm going to, oops, no, it's not going to let me, I'm going to do this. Take off this. I'm going to add and bring down the power of 10 after you add or subtract the exponents. Okay, you have to make sure that you do that. I didn't write that in there, but you need to make sure that you do that. So now it's there. Okay, so I'm going to do this. I'm not going to do that. I have overlapping things now that I added. So I'm going to slide this down. Okay, there we go. All right, so now let's look at some problems here. And I'm going to, oh, no, that's not what I wanted to do, because that's going to take away my writing. Mr. Shaw, what are you doing? I need to do this so that you can read this. It's hard to see it when it's highlighted. Okay, so now what you're going to do is we're going to actually practice or show you what this looks like, okay? Again, it isn't hard. There are just a ton of steps to it. And if you don't pay attention to the steps, you are going to make mistakes. So that's why I decided to type these out for you. because you can always refer back to these steps then. Okay, so this first example gives you a problem where you have 4.6 and 8.72, and they both have the power of 10 to the third power, the exponent of 10 to the third power. Because your exponent is the same, all you have to do is bring down your 4.6 and your 8.72, and you're going to add those two decimals together. And when you add those together, you get 13.32. Because our power of the 10 is the same, you're just going to bring that down times 10 to the third power times 10 to the third power. But this is not a proper format. Okay, 13.32 is not the proper format. You need that decimal to be between the 1 and the 3. So you're going to make it 1.332, and you're going to change that exponent to the fourth power. Because you're moving it to the left, you add that exponent on because you need to move it one more to the right when you multiply it out. So it becomes 10 to the fourth power. Now, in example B, your exponents are different, and this time they're negative. And again, this can get confusing. So you start out with 6.3, I'm sorry, 3.5 and 6.6. And you're going to subtract those two. 3.3 minus 6.6 gives, what are they doing here? Oh, they did the exponents first. I wouldn't do it that way. I would do 3.5 minus 6.6, and you're gonna, they did it, and they manipulated it a different way. I would have went 3.5 minus 6.6. And yes, you're gonna get a decimal, but who cares? So when you subtract that, you end up with, oh, I see they don't want to make it negative. I know why they did that. Okay. This is what they did, because they don't want to end up with a negative number, and I didn't even realize that it would be negative at first. Okay, so what they did is they initially manipulated the powers of 10 to make them the same, so that you ended up with 3.5 times 10 to the negative second, and then this 6.6 became 0.66 times 10 to the negative second. They manipulated it right away, so then you wouldn't end up with a negative base number. So then you take that 3.5 and that 0.66 and you subtract them. Then you can just bring down your negative 2, and you end up with 2.84, and you don't have to manipulate in the end. So that they manipulated it before they subtracted, so you don't end up with a negative exponent. So and that's a good that that's here, because you are going to probably want to do that, because you don't want to end up with a negative base number. Okay, so be aware of that. If you end up with a negative base number, manipulate it first. I think it's easier to manipulate it after, but if you get a negative base number, manipulate it first. Okay, so let's look at number 1. We're going to do number 1 together. So for number 1, you have 8.2, and I'm going to put this in black, 8.2 times 10 to the second. Okay, and then you have 3.41 times 10 to the negative first. So you are going to add that to 3.41 times 10 to the negative first. And you know what, I was getting mixed up above. You have to manipulate it in addition and subtraction. Multiplication and division, you don't. Okay, see, this is why I think it should be separate. So you have 10 to the second and 10 to the negative first. You need to make these exponents the same. So that 3.41 times 10 to the negative first, you need to make that to the second power. So 3.41, to make that to the second power, when it's, and I wrote this down on the bottom over here, when you are going for negative exponents, when you go to the right, it's more negative. When you go to the left, it's more positive. Where we need to go more positive, because we need this to be a 2. So for this to be a 2, if that's a 2, that's 1, that's 0, that's negative 1. That means I need to move my decimal 1, 2, 3 spots. Okay? So, but it needs to be, when you're doing negative exponents, you're actually going to be moving it to the left to make it more positive, not the right. It seems weird, but it's backwards, because we went to the right here, but because it's negative, it's backwards. So it's 1, 2, 3. So it becomes 0.00341 times 10, and then that would make it negative. Or I'm sorry, not negative, positive. See, I even did it. Positive 2. Okay? So now you can take that 0.00341 and add that to the 8.2. And when you add those two together, you end up with an answer of 8.2034 times, and then you just bring down your 10 to the second power. Now, I don't need to change anything because this is in proper format. You have a number with a decimal after. So there's no changing that needs to happen. Okay, so let's do number 2. I think we'll do number 2 together as well. I'm going to erase this one. So if you don't have it copied down, make sure you rewind and copy. Okay, so this next one is a subtraction problem. And it's 7.8 times 10 to the negative 5th minus 4.5 times 10 to the negative 5th. Well, our exponents are the same. When your exponents are the same, you don't need to do anything. You can just bring it down. So it becomes 7.8 minus 4.5. You're going to do the base numbers. Okay, times, and then 10 to the negative 5th, whatever you have here. So 7.8 minus 4.5 is 3.3, and then it's times 10 to the negative 5th. And again, because there is no, it already is in proper format, there's no changing that needs to happen. Okay, you can just leave it in that format. That's addition and subtraction. Addition and subtraction, you need to, just like I have over here, and I should have followed my own rules, you need to rewrite the decimal to make them in the correct format of the power of 10. So make sure that you have in the same power of 10 before you add or subtract your factors, because that's going to change your answer. Like in my example when I was doing it, and I was getting messed up with multiplication and division. Because in multiplication and division, you don't need to put it in the same power of 10. So, and I have my directions down here, what you do. When multiplying and dividing in scientific notation, your powers of 10 do not need to be the same. You multiply or divide the factor, the decimal, and multiply or divide the power of 10. If you multiply the power of 10, you add exponents. If you divide the power of 10, you subtract exponents. So then you place your answer of your factor in the correct format by manipulating the decimal and the exponents appropriately. And that's what you're going to do. And then I put a little note here. Remember, negative exponents, you go to the right for if it's more negative, to the left to make it more positive. And that is really huge because that becomes difficult. Okay, so when you're multiplying scientific notation, you have 3 times 10. The example they have here is 3 times 10 to the negative 5th, and then 5 times 10 to the negative 2nd. Now all you do is you bring down your 3 and your 5, and you multiply those together, the 3 and the 5. Okay? And 3 times 5 gives you 15. Then you look at your power of 10s. You have 10 to the negative 5th and 10 to the negative 2nd. So that becomes 10 to the negative 5th times 10 to the negative 7th, or 2nd, and that's the same thing that we did with exponents. So you add your exponents. So I would write 10 to the negative 5th plus negative 2nd. And that then gives you 10 to the negative 7th. Okay, now, you're not done yet because this is not in proper notation. 15 times 10 to the negative 7th isn't correct. It needs to become 1.5. Now, you can do what they did here. I don't. I know that, okay, I have a negative 7. I need to make it 1.5. So looking at this, that rule over there, where if you go to the right, it's more negative, to the left, it's more positive. So you needed to go to the left. So you have to, left is more positive, so you add a positive 1 to that. So it's 10 to the negative 6th power because you move that decimal over. And that really does get confusing with negative exponents, so you really need to pay attention to that. Division. Division is the same thing, except that this time you, instead of adding your exponents, are going to subtract. Otherwise, everything's the same. So you have that 1.5 times 10 to the negative 8th divided by 6 times 10 to the 7th. So you take this part, that 1.5 and the 6, and divide them. And then you subtract these exponents. So it becomes 1.5 divided by 6, and then it becomes 10 to the negative 8th minus 7. Well, that 10 to the negative 8th minus 7 becomes plus a negative, right? So 1.5, I got to make sure I'm on the right page here, 1.5 divided by 6 gives you an answer of 0.25, okay? Times, that should be a decimal down there, sorry. 10 to the negative 8th plus a negative 7 is 10 to the negative 15th, okay? So I need to move my decimal over again because it's over here, 0.25, and I need to move it to the right. And to the right, when you're dealing with negative exponents, is minus 1. So going to the negative. So if you move it 5, it's minus 5, etc. You're going to move your exponent. So you're actually adding a negative. So it becomes a negative 16 instead of a negative 15 times. Oops, that's not a negative 16, Mrs. Shaw, times 10 to the negative 16th power. 2.5 times 10 to the negative 16th power. This is very confusing, I know. Okay, so I would like to go over number 3 with you. Okay, so number 3, I want to do number 3 together today. So if you look at number 3 says 6 times 8 times 10 to the negative 5th power. Now, what that means is you're going to do 6, you kind of have to write 6 as in exponential form, or scientific form, I should say. So if I have 6, the whole number 6, that's going to be times 10 to what power? Times 10 to the first power to the 10 to the first would make this 60. 10 to the 0 power, 10 to the 0 power makes 10 1, and 1 times 6 is 6. So you're going to take that, you have to essentially write that whole number in scientific notation. So anytime it's just a number, you're going to multiply it times 10 to the 0 power, because 10 to the 0 power makes 10 1. Okay, and then you're going to multiply that times 8 times 10 to the negative 5th. All right, now, following our rules of multiplication, you're going to multiply your whole numbers together, 6 times 8, and that becomes times 10 to the, and then you're going to take, you're multiplying, so you're going to add your exponent, 0 plus a negative 5. Okay, so 6 times 8 is 48, and 0 times 10 to the 0 plus a negative 5 is 10 to the negative 5th power. Now, this is not in standard form yet. It's not in scientific form. So you have to turn that 48 into a decimal. So right now our decimal's behind the 8, right here, and we want it right here. So we need to move it one spot to the left. So it becomes 4.8 times 10. Now, it was negative 5th here, okay? We want it to be over 1, so that's going to make it negative 4th power. Now, if you're struggling again, because I said when it's negative, it does become difficult. If you're going this way, and this is only when it's negative. If you're going that way, it's the negative 1 or negative 2 or negative 3 that you're going to add. If you're going that way, it's a positive 1, positive 2, positive 3, depending on what you add, how many places you add. Okay, that can be very confusing. So make sure that you have a good understanding of that. The other thing you could do is you could take this 4.8 and think, okay, 48 times 10 to the negative 5th, 48 times 10 to the negative 5th would make this a 1, 2, because it's negative, we go smaller, 3, 4, 5. That, oops, sorry. That means that I have a decimal and then 1, 2, 3 zeros in front of it. So I need to make, when it's 4.8, I need to make the same answer. So if it's 4.8, again, I need to have 3 decimals in front. That's 1, 2, 3, 4. 0, 0, 0. and that comes out to, it needs to be an equivalent answer. So if you're not sure, you could work out your problem and figure out where you need to go to make it what you need it to be, okay? All right, so now I'm going to ask you to pause your computer, and I'm going to ask you to do number 4 and number 6 for me. Pause your computer and do 4 and 6 for me, please. Okay, so number 4. Number 4 is 7 times 10 to the second and 3 times 10 to the fifth, and we are going to multiply those. So you have the 7, and I'm just going to rewrite them over here. 7 times the 3, you take your factors and multiply those. And then you're going to multiply that whole thing times 10 to the second plus fifth, because we're adding. Ooh, that doesn't look like a very good 2. Second plus fifth power. Because we're adding, we are multiplying, we add our exponents. So 7 times 3 is 21 times 10 to the 2 plus 5. 2 plus 5 is 7. 21 times 10 to the 7th power. But again, we need to move our decimal. It's right now it's after the 1. We need it before the 1, between the 2 and the 1. So you're going to be moving it to the left. So it becomes 2.1 times 10 to the, and because we're going to go, we have to go to the left, we're going to have to go an extra loop to get it to be where we need it to be. So that's going to be to the 8th power. Okay. Now you're going in and to the left, so you are going to add that 1 to it. Okay. I guess this does kind of work for that too. So that's what your answer would be for number 4. Okay. If you got that right, awesome. If not, you're going to need to go back and rewatch to make sure you understand it. Okay, so let's do number 6. Number 6, you take that 1.5, and we're dividing this time. So you're going to take 1.5 and you're going to divide that by 7.5. Okay, and then you're going to multiply that times the power of 10. So it's 10 to the, and we have negative 3 and 2. So we subtract a negative 3 minus 2 for your exponents. But that becomes an additive inverse plus a negative 2. Okay? So 1.5 divided by 7.5, I look at my notes, is 0.2. 0.2. 2/10. Okay? Times, and now we have 10 to the negative 3 plus negative 2 is negative 5th power. We were subtracting, but it turns it into an addition problem. Now this is not the correct format because we want that decimal to be to the right of that 2, not to the left of the 2. So that becomes 2 times 10 to the, okay, so we have negative 5, and we are moving our decimal to the right. When we move it to the right, going right, we add whatever the negative of that. So that's going to be a negative 6 because we have to add a negative 1 to it. You're going more negative instead of more positive. And that would be your answer for number 6. Okay? If you did that right, you can move on. If not, you should really rewatch. Okay, then there are some word problems too where you're just going to take the words times greater means multiply, divide, or I'm sorry, dividing, well here what they're asking for is how many times greater is the diameter, so actually you're going to divide what they give you for the sun, and then I think it's the sun, yep, the sun and the earth. Okay, so you would divide those exponential forms because you're trying to figure out how many times greater. And then if they're going to ask you if it is this many times greater, how much would it be, then you would multiply. Okay, so we're going to skip those for right now on your video, and I would like you to do problems 3, 7, and 17. 3, 7, and 17 as your practice problems. 3, 7, and 17.